Okay, good afternoon. This is Mr. Precella, and we're going to pick up where we left off on Monday, working through the Math 0314 final quiz. Review, that's right. And it's what? We're ready for number 7, and they give us a function, h of x equals x plus 20. They ask us to find h of 0, and we know that that means go to the function h, and wherever we see an x, we're going to replace it with 0. 0 plus 20 gives us a final answer of 20.
Most people could probably do that problem without writing anything down.
I'm just showing off my perfect penmanship.
I know.
Tony won a couple of them.
One?
Okay. One year he won penmanship. But,
Just take the second one.
h of negative 2.
You know, this is one of those they might be able to do.
18.
Yeah, that's right. Negative 2 plus 20
I'll show all that perfect penmanship.
equals 18. Okay.
18.
Let's see what the next one is. I bet y'all can tell me this answer without me having to show any work.
5.
Negative 15 plus 20, I agree, is 5.
Oops. Ooh.
What about
this
h of 13?
Oh, 33.
13 plus 20 is 33, I agree.
Oh gosh, how many is it? Okay.
Oh, here's one. Okay, I want to do this one. H of
b plus 11. Whatever's in the parentheses, you plug it in for x.
Okay, so you go up there to x, replace it with b plus 11. You still have that plus 20, and 11 plus 20, I certainly agree with the answer b plus 31.
b plus 31. Oh, okay, we're finished with that one.
Okay.
Oh.
Number 8. They give us two ordered pairs that are on a line, and they ask us to find the slope of the line that goes through those points. The ordered pairs 1, 2, and what's the other one? 4, 6. And we had a formula. We could just plot the points and count rise over run, but I only use rise over run if they give me the graph. Otherwise, I use the slope formula. Okay, y2 minus y1, that's what's on top. That gives us the rise, or the vertical movement, over x2 minus x1. I agree.
So second y minus first y over second x minus first x. What did you label all?
I know. That's what I was going to do. We have an ordered pair. This is the first ordered pair. There's the first x and the first y. Here's the second x and the second y.
Make sure you're going x, y, x, y. Sometimes I've seen students go x1, x2. No. Ordered pairs are always x, y.
Okay. So it's the second y minus the first y. So 6 minus 2. What goes here? 4 minus. And what is that? 4 over 3, 4/3 for my final answer. Any questions there?
Yep, what?
No, I don't think they're asking us to do that yet.
My glasses have been ordered.
Oh, that's wonderful. Oh.
I'm sitting here going.
Wait a minute. Can we? We're gonna make it bigger.
Don't worry about it.
Control Shift plus.
Okay. Yeah, and I'll do this.
Yeah, okay, thank you.
How about that? Probably never done it like that before.
Oh, wow, look at that. That's some of the stuff we were doing at the last time or the time
Last
before
week.
that. Solve the following system of equations by elimination. So this is number 9. They're telling us to use elimination. 6x plus 3y equals negative 12. And 3x minus y is equal to negative 1. Even if they hadn't told us to use elimination, if they'd given us a choice, substitution or elimination or Kramer's rule, I still would use elimination. Which variable do you think I'm going to eliminate? The y. Notice we already have opposite signs, one positive, one negative, but we need the same number. What do you think I'm going to do? Okay, we can multiply everything in the second equation by 3. We'll distribute through a 3, and that's going to give us there. The second equation is going to become a 9x. What else? Minus 3y equals, good.
For some reason, this looks like a 13 to me. Don't try to change it or else it'll wind up looking even worse.
There, it's
okay.
there.
That's a 3.
And the top equation stays the same. And we'll add the two equations together. Adding the x terms together, we get 6x plus 9x. I agree with 15x. What's about to happen with the y terms? Okay, that's why they call this elimination. We've just eliminated the y terms. Wait a minute, equals...
Oh, but go ahead of you. Negative 15.
Negative 12 minus 3 is negative 15. Okay, that's where you're getting the negative 1. You then divide, okay, to give x equals negative 1. Okay.
I think I said positive 1, but I wrote negative 1.
Oh, I thought I heard negative 1, but
You said it.
either way, that's where the 1 was coming from. I was thinking, they're seeing 2 minus 3. They're not seeing that 1 there. That's what was happening. Okay, but now I see where you were answering the final x value. Now what do we do to find the y value? Plug back in. Which equation do you want to plug into? It doesn't matter. This one right here, so we have 3x minus y equals a negative 1. We'll plug in a negative 1 for x. 3 times negative 1 minus y is equal to a negative 1. That's a negative 3 minus y equals a negative 1. You know, I wouldn't do that. I think I'd move this minus y to the right. Because if we move that minus y to the right, it's going to become a positive y. So we'll have a positive y over here. But then we have to move this minus 1 to the left by doing what? Adding 1, negative 3 plus 1. Okay. Any questions on my logic there?
There's certainly nothing wrong with just adding 3 and then dividing by negative 1.
There's certainly nothing wrong. You're right. So that says that these lines intersect at the ordered pair negative 1, negative 2. The x value was negative 1. The y value was negative 2. Any questions on my logic there? Okay.
Down here.
Shrink it down.
Okay.
I think that's sort of
Yeah.
there.
Okay, so we have the solution is, and I forgot what it was.
Negative 1, negative 2.
Negative
And be sure to
1,
type it as an
comma,
ordered pair.
Negative 2, close parentheses. Okay.
Okay, substitution. It's another system of equations.
You know what? If I were a student doing this problem,
I'd still use
I'd
elimination.
multiply that top equation by 3 and use elimination. But, okay, we'll do substitution because it says substitution.
Okay. 3x minus 3y, 4x plus 4. Okay. And here it says use substitution.
Okay, so what would we do to start with substitution? Or to do substitution? Take them here.
Okay. So we have to solve for one of the variables. And there's only one sensible letter to solve for. Y in which equation? The top or bottom? The top. Try to solve, if there's a variable that just has a 1 as its coefficient, that's the one you want to solve for. So solving for y, we get y equals 19. Move that over to get...
She said my ears were burning? What did you say?
I didn't. They said.
Okay.
I never miss class.
Move the 4x over by subtracting, right?
Everyone's doing elimination.
Oh, everyone's doing elimination. Okay.
Even though I was late, I still was late.
Oh, okay. Better late than never.
Then we take, just like the name implies, we take what we've just found and we substitute it into the other equation. So we have 3x minus 3. Replace that y with 19 minus 4x equals, what do we have here on the right side? 3. Just checking to see if you were following. Let's see. There's really only one sensible next step. What is it? Distribute. Here. And here.
Next sensible next step. What if they had said, stop that and do elimination?
I suppose they said to divide 3 by a factor of 3.
That would have been really smart.
If we're going to do that, you should have done it at the very beginning of the problem. Okay, so we distribute the 3. Negative 3 times 19 is a minus 57. Negative 3 times a negative 4x is plus 12x. And we still have that 3 there. Okay, so we'll add the 57. So you're adding 57 to both sides. That's a good thing to do right there. So on the right side, what are we going to have? Okay. And on the left side, we have a 3x plus 12x. You said that is 15x. And then you said divide by 15. To give us x equals, I think it's 4. 60 divided by 15 gives me 4. That means these two lines are going to intersect at an ordered pair where the x value is 4. We need to find the y value. How will we do that? Okay, now when I'm using substitution, the one that I substitute back into is always the one where the variable's already been solved. That's the quickest thing to do. We're trying to find y, so use the equation that's already been solved for y. Take that 4, plug it in right there. So we have y equals 19 minus 4x. Substitute in the 4 that we just found. That's 19 minus 16, which gives me a y value of, I agree. So we have the ordered pair, 4, 3. Once again, if you had used elimination, you would expect to get the exact same ordered pair.
Which one's easier?
Oh, elimination is easier, especially if you don't have a variable with a coefficient of 1. Now, if you have a variable with a coefficient of 1, then they're both about the same. But elimination, I think, is easier if you don't have a variable with a coefficient of 1.
Yeah, imagine if there were 7 in front of this y, and you had to divide 3 by 7 and plug that in, you know.
Okay. Any questions there? Did you punch in the answer?
Uh-huh.
Okay.
Are we ready for number 11? Sort of flying through this. Oh, it looks like this final quiz is going to have a lot of these elimination and substitution stuff.
A basketball player scored 31 times during one game. She scored a total of 52 points, 2 for each 2-point shot and 1 for each free throw. How many 2-point shots did she make? How many free throws? I remember the basketball problem. I remember doing one similar to this, but I could swear that the other question asked he scored a total of 52 points. So I think they're changing the pronoun, the gender within each problem.
Just to make it different.
Table that you like so much?
Yes, of course I'm going to make a table.
Well, the
Let's
table
see.
worked very well in those last 4 questions.
Okay.
Well, that's what we're
But
going
you
to
have to know the unknowns. If you're going to make a table, you have to be able to figure out what the unknowns are.
And
what are
generally
the 2
the
things?
questions give it
The
away.
general, yes. Okay. How many 2-point shots did she make? How many free throws? So I'll say 2-point and free throws. And I'll say shots made.
X and Y.
Okay, those are the things we don't know. So we'll label them X and Y. And
I'm going to see that.
go back, let's see.
And then points made.
Okay, how about the points per shot? I'll say the points,
Or you could just say point.
I'll just say points for brevity. Okay, so each 2-point throw was worth 2 points. Each free throw was worth 1 point.
I feel like we did something very similar on Monday.
Mm-hmm.
To the problem?
Yeah, go back to the problem because we still need more information to fill in this table. We need some totals here somewhere.
So
52.
X, Y, and then 31 under that, and then the other one would be 53.
Okay, so she scored 31 times. She scored 31 times. So if we total the number of free throws and the number of 2-point shots and the free throws, that'd better total up to the 31 times she scored. If we total all the points, yes.
And then your equations would be X plus Y equals 31.
Okay, X plus Y equals 31.
And then it would be 2X plus Y equals 52.
Oh, switch over. Yes. So it's
I was writing
take
it out,
the number of 2-point throws and the number of free throws, combine that better be 31. Then you go points per shot times the number of shots. That gives you all the points that she scored with those 2-point shots. So 2 times X plus points per shot times the number of shots. 1 times Y is just Y equals.
You'd multiply the top by -1.
Yeah, okay, so it sounds like you're using elimination with the goal to eliminate which letter? The Y, I agree. That's probably the cleanest thing to do. We're going to multiply the top equation by -1. That's going to give me a, keep going. Okay, I agree. And the second one is just added together. I mean, it stays the same. The second equation was not changed. We add the two together. Oh, this is working out nicely.
We cancel off the y's.
Okay, and then -1x plus 2x gives us a positive 1x equals -31 plus 52. I agree with 21. So this basketball player scored 21 two-point shots during the game. We know X is 21. Well, how many total shots did she make? If you understand what they're asking for, you can figure out that Y value without any work. 21 plus what gives you 31? I agree, 10. Or you can plug in the 21 plus Y equals 31. Subtract 21 from both sides. Either way, you're going to get Y is equal to 10. 21 two-point shots and 10 free throws.
21 two-point shots and 10
free throws.
Another one like the last time.
Yes, I think we decided these were picture frames. A woman bought some large picture frames for $15 each and small frames for $7 each at a closeout sale. If she bought 27 frames for $253,
That's crazy. What is she
find
doing
how
with all
many
these
of each type she bought. Someone was mentioning hoarding toilet paper earlier, okay? I think she's hoarding picture frames.
When the great picture
Frame shortage comes and that
she'll
crunch
be ready.
comes, she'll
At
be
that point,
ready.
She'll get up her picture frames and start selling them for $1 million.
It was the $7 one when he's only making like minimum.
Oh,
Oh,
I
yeah.
know.
Oh.
That was depressing. Hopefully that's not here, okay?
Oh, it will be.
Okay.
Probably after this.
How many of each type of frame did she buy? Sounds like there are two unknowns. Okay. How many large frames? Oh, yeah. Large and small.
It's just going to the Bed Bath and Beyond liquidation sale.
I know.
Now that's depressing.
Yeah. Remember, there was a time in my life when
It seemed like we go there every week.
and
Okay.
then something happened, and
Things change.
yeah.
Okay, so how many small frames is she buying? X and Y. I'll just say number bolt. She bought X large frames and Y small frames. And those large frames, let's go back. Well, we know the cost per item. We know cost per item. The large frames are costing her $15, and the small frames are costing $7. I think we need some totals here, though.
27 frames.
She bought a total of 27 frames. Where's that 27 going to go? At the end of this XY column or at the end of the 15-7 column? The XY. She bought a total of 21 frames.
23.
23? Well,
No, 27.
27 frames. Okay.
She's getting ready.
I know it.
She's crazy.
Okay. And she spent a total of how much money? If we total all the money.
$253.
That's just too much.
Oh. Maybe she owns an art gallery and she has
She's
to.
gonna sell it.
Yes, at a
She gets
much.
her money back.
She's
Surely
going to
she
put
will.
one of her paintings in them and sell them for $5 million each.
Yeah. Okay.
I don't think I'd buy a new wristband.
I'd say something, but it's not proper for recording.
Okay. We need two equations. Remember, I said that the number of unique equations should equal the number of unique
You
variables.
said that last time. I don't think you said it.
I didn't
today.
say that. I know.
Plus y equals
Okay, so the number of large frames plus the number of small frames had better equal the 27 frames that she bought. That looks like 127 there, doesn't it?
Yeah, whenever you start trying to correct something, it just gets worse and worse.
No, I think it looks better there. I can
Oh,
clearly
okay.
tell that's 27 now. Goodness, Tony, I think you're still thinking about my penmanship awards, aren't you? Okay? Green is not your color, Tony. Okay?
Green
The
is not
second.
color, period, for y'all. Like, every time you use green, you freak out.
Oh.
No, I just meant to
You
wear.
missed what the whole
Okay.
conversation was.
So, okay,
Green
I'm
is
waiting
good.
for another equation.
15x.
Okay, so you to go cost per item times the number of items. And do you understand that that's saying how much money she spent on all those large picture frames? Each large picture frame costs $15. Multiply it by the X frames she bought. That's the money she spent buying large picture frames. How much money did she spend buying small picture frames?
71.
So the price per item times the number of items equals the 253. That's one thing. You know, I'm of the mind.
What?
I don't like the variable y because of these curly tails. I think
I don't
everything should
write a
be
curly
X
tail on
and
the dog
W.
when I ride it.
If it were X and W, no curly tails. So when Tony and I take over the world, that first rule, remember the first law was going to be all variables had to be X and Y, X and W. X and
You have the
W.
little on the roots.
Oh, but Tony and I are still debating that. Tony doesn't like my little thing at the end of the square roots. Okay. Y'all tell me what y'all want to do, elimination or substitution?
Multiply -7 on the top.
Okay, so you're going to eliminate the y's. You're multiplying by -7. You want the same coefficient but opposite signs. So that's going to give us,
-7 minus 7y.
I think it's -7x minus 7y equals -7 times
27.
27 -189. I agree.
Carry over the other.
Okay.
Out the way.
Wait, let me write it down.
X equals 64.
You know, Tony, maybe the reason you didn't win those penmanship awards is you wouldn't make those curly tails on the Y's. What are y'all getting here? -7x plus 15x?
8x equals 64.
Okay.
So then x equals 8.
Okay, -189 plus 253, I agree, is 64. And then divide by 8
X equals 8.
to give us x equals 8. So she bought 8 large picture frames.
And then you take the 8 on the top row, you take the x plus y equals 27, you put 8 plus y equals 27. Carry the 8 over, which means y equals x.
Okay, 27 minus 8 gives me 19. I agree. Okay.
Give me just a minute here.
Yeah, but she bought 27 frames altogether. 8 of them were
The
large.
stuff from, like,
The other
beginning, I'm like,
19 have to be the small frames.
about the final
Oh, no.
quiz, I'm okay with.
Oh, okay. Any oh, wait, you know what I need to do? I need to punch this answer in, I hope.
What, just get timed out?
There were 8 large,
18
Yeah.
or 9.
Oh.
I'm sorry, 8 and 19.
8 and 19.
Yes.
Okay.
Oh, this is
wow.
good.
Okay, we're through with those 4 points.
Okay.
Any questions here? Let's see. Huh?
Okay. Number 13. Solve the equation analytically. I remember this. Those exponential equations are equations where the variable occurs in the exponent. 3 to the 2x minus 5 is equal to 81. Okay. We're trying to use the common base method. That's my preferred method. If we can't get a common base, if it's impossible, then we use logarithms. But here we can rewrite the right-hand side using the power 3. We can say 3 to the 2x. Recopying the left side. 81 is the same thing as 3 to the power 4.
See, multiplying 4 threes will get you an 81. What's funny, Jennifer?
I think she was thinking 3 to the 4th was 12.
No, my
No.
coffee is
Oh, no.
I'm a little goofy.
Okay.
That's good. I'm getting a little goofy because they're so close to the end of the semester. I'm still entertaining the notion of just giving y'all all incompletes and say, come back in the fall and we'll do it all again.
And you'll have to deal with this again.
That'll be summer.
Yeah, but
Only
not online during the summer. Okay,
Okay.
drop the basis, set the exponents equal. That's right. I'm waiting for y'all to tell me what to
Bases
do.
are equal, the exponents have to be.
2x equals 4 plus 15.
So 4 plus 5 gives 9, and
You said
then
15?
What did I do?
Uh,
I wrote down 15.
you wrote 15, but oh, you said 15 and
Did I
wrote
say-
5.
It's my eyeballs.
Oh, no,
Right over 2.
it's a 5 definitely. Okay, so you said 15, it's 5.
That's the answer, right? It's 9/2.
9 over 2.
9 over
Do
2.
you put the x equals?
Look and see how it, look at how it,
Sometimes it, like,
Oh,
I've gotten wrong on tests because I didn't put the x equals.
no.
Yes. It's the axis one.
See, I'm not alone.
Oh, no, oh yeah, because
But
it says
the
find
axis-
an equation. It doesn't say find a
The
solution.
ABCD F1.
An equation is, you're writing the
I don't
Equation
think
of
I
a
got it
vertical
wrong, but I
line.
think I
A
got it
vertical
wrong on my
line has
homework.
x equals.
I got it wrong on my homework, not on the test, but
Oh,
I
okay.
just want to make sure there's nothing else other than when it's like the domain and the
Oh, wow, look at this. Okay, so we're going to be graphing using the little graphing tool. Okay, for the equation y equals x squared minus 5 create a table with at least 3 ordered pairs that are solutions of the equation, and then graph the equation. Look, they give us the table. I'm going to make that table. I'm going to draw. Oh, yes. I mean, there are good ways of summarizing information. So we're going to be using -2 for x, 0, and +2. So, oh yeah. No. Well, you know something, Tony? That thing needs to be raised.
And that's A.
Pardon me?
That's A.
We have to fill in this table, and then we draw the graph. But this says take the -2, plug it in for x, so we have -2 squared minus 5. Okay, that's a 4 minus 5. I agree with the -1. So there's my first order pair, -2, -1. This says go plug what number in for x? 0 minus 5 gives me, here we're plugging in 2 squared minus 5. That's another 4 minus 5, so another -1. So,
-1, -5, -1. -1, -5, -1. Check it.
now, do that. Oh, okay. Oh yeah, popping it out. I guess that's better.
Okay.
Okay, we got to choose the tool we need. Y equals x squared minus 5. What sort of a tool are we going to use?
Here your choices are line. Definitely not a line. It's not the absolute value. This is the 3-point quadratic tool. We had 2 quadratic tools.
Yes.
One of them said find the vertex and so forth. Here, we're just using the 3-point quadratic. We click here, and we,
Well, you blew it up.
I
It's
blew
not
it up
showing.
too much. Okay. Okay. Oh, you can pin
Yeah, shrink it down.
down more. Now,
Which one do you start
Okay.
with graphing? The -2,
There.
-1?
No, with the 3-point tool, it didn't matter.
you just go
Just-
through the 3.
We choose the tool that we want, and then it says plot the first point. It doesn't matter. I'll just plot the points in the order I found them. -2, -1, is that it? Yes. And then 0, -5. So left, right, 0, down 5, there. And then finally, the last point, to what? Notice as you move the cursor, it's drawing every parabola that's possible containing those first 2 points.
Even a line containing
Because
just
your
Uh-huh.
equation, the x is positive, it's going to be an upward parabola.
Oh, wait.
Yes, because the coefficient in front of x, that
If
x
it's
squared.
negative, it would be an
Hey, Tim, I think you were at the, you're going to
No.
drag it?
No,
You were at 1 -1, not 2 -1.
I thought it's 2 -1. Oh, you're right. Well, shoot. Let me
I'm
start it
sorry,
all.
I
No,
interrupted
I
you.
went to the wrong point.
-2, 1, or
-2, -1,
5.
0, 5, and then +2, -1. Save it. It's been transferred over here. Check. I would imagine in the 13-14 test, you'll have to use the other graphing tool. I bet you it'll be the 2-point quadratic tool, and you'll have to find the axis, the vertex, all of that stuff. Hey, is this going to be a parabola? Look at this equation. We're at number 15.
Parabolas have x squares. This is just going to be a little squiggly curve. Yes,
Right.
it's a squiggly.
And they give us a table. Let me write the table out. We're going to have to plug in -1, 0, 1, and 2.
And then you just plug that -1 into the
Okay.
So we come over here. We're going to plug -1 in for x. So we have -1 cubed plus 4. What's -1 times -1 times -1? -1 cubed is -1, correct. Plus 4 gives me a y value of 3. So there's my first order pair, -1, 3. Now plug in 0.
0.
0 to any power is 0 plus 4 is
Negative
0 plus 4.
0 plus 4 is 4.
Oh, okay. Okay. Plug it in a 1. Maybe I better write this out. 1 cubed plus 4. 1 cubed is 1 times 1 times 1 is 1 plus 4 gives us 5. Plugging in 2. Notice these 3 points right here. If you plotted them, it'd look like a line. But as you start moving away from past 1, I think the graph is going to start getting very steep very quickly. At 2, we'd have a 2 cubed plus 4. 2 times 2 times 2 is 8.
Not 6. Not
Plus
10.
4 gives me 12.
Any questions how we got these numbers here? The 3, 4,
2
5, 12.
times 2 times 2. 2 times 2 is 4. Times 2 gave me the 8. Plus 4 gives me 12.
Are we ready to punch those numbers in? What are they?
3, 4, 5, and 12.
Okay. Oh gosh.
Let's see.
So do you graph all 4?
Yeah.
Well, what tool are we going to use?
Okay, the squiggly. Notice if we hover there, it says 4-point cubic tool. Jennifer, can you see it?
No, but I assumed it.
Oh, okay. I was going to say, you can
I
see
was like,
pretty
how
good
did
up there.
you know?
Wow. Oh, wow. So we click it. It says plot the first point. -1, 3. Oh.
-1, positive.
-1, positive 3.
Oh.
Is that it? Click it. And then 0, 4. Is that it? Yes. And then 1, 5.
Look
That
at it.
sure looks
right
like a
now, it
line.
looks like a line.
It sure looks like a line right there, doesn't it?
Yeah.
But plot that fourth point.
2, 12. Right 2, up 12. Notice it's becoming dramatically steep on the right and left side. Before I go on and transfer it, suppose we plugged in 5 for x. 5 cubed is 125 plus 4. So when we've gone 5 to the right, you have to be 129 units up in the air there. So notice how steep it gets very quickly. Save. Check answer. Any questions there? Now this ends the 314 final quiz review. So I'm going to stop recording. No,